Okay, today we're talking about real-world data with matrices and how to use a matrix to set those up. You're going to be able to set up and define the matrix and perform operations on the matrix by the end of this video. When we talk about a matrix, we talk about it being called matrix A. We use capital letters to describe our matrix if it doesn't have a title already. The rows are on the side. Rows 1, row 2, 3, and 4. Columns go the other way. So rows across, columns down. So our matrix in this case would have a dimension of 4 by 3. It's rows by columns. Always rows by columns. You need to remember that. Okay, the element. If we talk about the element here, we want to know that R1, column 1 element, that would be 3. If we talk about row 2, column 3, row 2, column 3, that would be 7. Those are elements. Okay, those are the numbers in the matrix. Okay, two matrices are equal if and only if they have the same dimensions and are identical, element by element. Find the values of x and y for which the matrix is true. To do this, we simply say y is equal to 2x minus 6, and then again we write x equals 2y. Oh, I've got two variables, two equations, so I have a system of equations, and I use substitution. I think the way that I would go about this is simply put y equals 2 times 2y minus 6. I plug the 2y in for the x and then solve for y. So as I solve that for y is equal to 4y minus 6. And as I finish that up, we get negative 3y is equal to negative 6, and y is equal to 2. If we know y is 2, I plug that back in up here. Plug it in right there. And x then would equal 4. So my solution here, my x and y that I would need to make this equal are x would be 4 and y would equal 2. So, falling back on the information that we just studied, solving systems of equations. Well, example 2, just like the last one. We have the problem 4x minus 3y equals 11, and x plus y is equal to 1. This time I want to use the elimination. So by eliminating, I want to multiply this by positive 3. So we multiply by 3. That new equation becomes 3x plus 3y equals 3. So I write the first equation down. 4x minus 3y equals 11. I write the new equation down, which we said was 3x plus 3y equals 3. I now have variables y that are going to eliminate from each other. They cross each other out, and I get 7x is equal to 14. Therefore, x equals 2. If x equals 2, I plug that back in. I plug it right into that one. 2 plus y is equal to 1. If I subtract 2, y equals negative 1. So I have a solution again. X is equal to 2, and y equals negative 1. When we add matrices, we add the elements. Simply 2 plus 8, that gives us 10, equals 10. Negative 5 and negative 9, that would be negative 14. 4 plus 1 is 5. And finally, 3 minus 3 would be 0. So you just add or subtract the elements one piece by piece. in scalar multiplication. Folks, this is enlarging the matrix, in this case, by 3. We want a new matrix that is 3 times larger than the last one. This is like distributing in multiplication, and you're going to multiply every piece by 3. So our matrix would become 3, negative 15, 12, 21. As you see, every element is just 3 times bigger than it was. Okay, at this point we're going to be talking about matrix multiplication, but the best way I think we can do that is by putting it in terms of context. How would we actually find out this information? And I want you to work through these problems, and then if you've got questions, we'll talk about them tomorrow during class. So 2 sports stores quote prices for a league. There are 3 teams in 8 uniforms. The size and price information is written in matrices. What store has a better price for each team? What does the number in row 3, column 2 mean? Now the last 2 sentences is different than what's on your notes, so you make sure you answer what's on the screen and not on your note page. Make sure you bring your textbook to class tomorrow on 1/27/17 because we have some homework on page 83. See you tomorrow. Thanks, guys. Bye-bye.